Section 3.6 is on ratios and proportions. A ratio is a comparison of two numbers by division, and like the ratio of A to B can be expressed in the following ways. You can either write A to B, you could write A colon B, or you can write A over B. I think often we do top and bottom more often. For example, you can express the ratio of males to females in a class as a 2 to 3 ratio. So you could write it like this, or you could write it like this. When I have two ratios and I have an equal sign between them, it's called a proportion. So you can look at this and you go 4 over 2 is equal or proportional to 8 over 4. To determine whether a ratio is equal, there's two ways. The first way would be to reduce both fractions and compare them. So 24 over 30, I could divide both of them by 6, and that would give me a 4 over 5, and then I can compare and I go, oh, 4 over 5 equals 4 over 5. So yes, they are proportional. I can look at it and go like this one. I can go, well, if I multiply the top and the bottom by 7, I would get this other one. So I can tell you that if I divide the top and the bottom here by 7, it's going to give me 7 over 8, which matches my number. So if they're both reduced to lowest terms, then I can often tell whether they are equal or proportional. But then often you have proportions that are like this, that you can't reduce them and see if they're equal. So what you do is you multiply the extremas, which is this one and this one, together, and you multiply the means together. Or another way that we say this is you cross multiply. So I cross multiply here and I get 0.56. I cross multiply here and get 0.56. So I know that those two ratios are equal. So I have a proportion. If I cross product here, I'm going to have a 0.50. And if I cross product here, let's see, that's going to give me a 30, 15. And that's going to give me a 0.75. So I can sit there and go, well, 0.50 and 0.75 are not equal to each other. So therefore, I can put a line through that and say that those proportions are not equal. Sometimes I have a variable in a proportion problem, like you see this n, and I'm supposed to solve and figure out what that n would be. So again, I'm going to cross product both of them, and I'm going to put the one with the variable on the left hand side. So I'm going to use this as scrap paper down here and do 24 times 15. So I get a 360 right here when I multiply 15 times 24. So now I look at that. The 16 is multiplied by the n. So I'm going to have to divide to get rid of it. So on the left hand side I have an n. On the right hand side I'm going to take 360, divide it by 16. It's going to go 2 times. It's going to go 2 times again. And then it will, and I move my decimal straight up, and I can add a 0 and bring it down, and that's going to go in there 5 times, and that's where it will come out even. So this is 22.5. That's what n is equal to. That would be what would make these two ratios equal, or what would make those two ratios a proportion problem. Same thing here. Going to cross product. So I have 8 times n is equal to 36. I'm going to divide by the 8. And I'm going to get n is equal to, and I'm going to come over here and divide the 36 by the 8. It's going to go 4 times, so it's 32. I'll add a decimal and a 0. Move the decimal up, bring the 0 down, and that's going to go 5 times. And that comes out even right there. So I get a 4.5 as my answer. A rate is the ratio of two measures that have different units of measures. For example, I could say 1 dozen eggs sells for $2.75. So if I want to know the ratio of eggs to cost, I would say 1 dozen to 2.75. So that would be my ratio or my rate of eggs to cost. 120 miles in 2 hours, I would say 120 miles over 2 hours. Now I'm going to reduce that to lowest terms, and I'm going to get a 60 miles per every hour. So that would be a ratio, a 60 to 1 ratio. I can cover 60 miles in every hour I travel. I could say a salary of $55,000, and I would say per 1 year, and that would be the rate that that person gets paid. So these are example problems. Now what I would suggest you do on these is you figure out the units you're talking about. So up here we are talking about eggs and money, miles and hours, and then money and time. So Trent, that should be goes on a 30-mile bike ride every Saturday. He rides the distance in 4 hours. At this rate, how far can he ride in 6 hours? So I have miles and I have hours, and I would encourage you to go ahead and write those down. That way you'll know that you want to put the miles on the top and the hours on the bottom. So I know the rate he goes is 30 miles, and he does that in 4 hours. So 30 miles goes on the top, 4 hours goes on the bottom. And then I want to know at that same rate, so a proportional time, how far can he ride in 6 hours? Well, the 6 hours would have to go on the bottom because I know that I'm putting hours on the bottom. That's why I went ahead and wrote that. My unknown is up here. That's how many miles he can cover in the 6 hours. So just like I did before, I'm going to cross product. So I have 4n is equal to 180, and then I'm going to divide both sides by 4, and I'm going to get, that's going to go in there, 4 times 45, okay? So if I divide 180 by 4, I get 45. So he can travel 45 miles in 6 hours. Here's another one. The gear of a bicycle is 8 to 5. This means that for every 8 turns of the pedal, the wheels have to turn 5 times. Suppose the bicycle wheels turn 2,435 during a trip. How many times would you have to crank the pedals? So the two categories I have is I have pedals and I have wheels. Okay, so I have 8 turns of the pedal for every 5 turns of the wheel. And then it says the wheel turns for 2,435. So that one's going to go on the bottom because that's where I'm writing wheels. That's why I put the categories there. And my unknown is going to go on the top. So I'm going to cross product this and cross product this. So I have 5n equals, I'll come over here and multiply this. So I have 19,480. And now I have to divide both sides by the 5. And that's going to give me my answer because those cancel out. So 5 into 19,480. That would be 3, which would give me a 15. Subtract. And I'm going to do 6. And then I'll do 9. And then I'll do 6 again. And that's where it comes out even. So I know that if the wheel turns 2,435 times, then the pedal would turn 3,696 times. A scale is a comparison between a model and an actual size. For example, you typically would have a scale on a map, or you would have a scale when you go to do a model car. So the two categories here are always going to be map and actual, or they might be model and actual. The scale of a map of Crater Lake National Park is 2 inches is equal to 9 miles. The distance between Discovery Point and Phantom Ship Overlook on the map is 1 3/4 inches. What is the distance between these 2 points? So I'm going to set up a proportion, and I'm going to have inches, which is on the map, and I'm going to have miles, which is in actuality. Okay, so that's the inches and the miles is going to be the map, and this is going to be the real or the actual one. And I know that I have 2 inches for every 9 miles. Okay, so that's my scale. I'm looking to figure out how far apart on actuality 1 3/4 inches. Well, that is the same as 1.75, and what I don't know is that down there. I don't know how many miles that is. So I'm going to use proportions to cross multiply. Proportions can be used on so many different word problems. Okay, so I have 2x, and then I want to take 175 and multiply it by 9. So that's 45, carry my 4, 63 plus 4 more is 67, carry my 6. 9 times 1 is 9, plus 6 more is 15. I have 2 places to the right of the decimal, so it's 15.75. But notice that my x, I'm multiplying by 2. To get rid of something that's multiplied, I divide. And that's going to give me my answer. So I'm going to take 15.75 and divide it by 2. Bring my decimal straight up. Bring the 7 down. That's going to go 8 times. Bring my 5 down. That would go 7 times. And then if I add another 0 and bring it down, it will come out even right there. So x is equal to 7.875. So 1 3/4 inches on the map is equivalent to 7.875 miles in actuality. Here's another example. On the map of Connecticut, the scale is 5 inches to 144 miles. So for every 5 inches on the scale, it's equal to 144 miles in actuality. What is the distance represented by 2.5 inches on the map? So again, I have inches, and I have miles. So 5 over 144. And then I've got this 2.5, which is the same as 2.5, and it's inches. So it goes on the top, and n goes on the bottom. I'm going to cross product, so I get 5n equals, have to multiply this over here. Okay, I have one number to the right. So I have one number to the right there, so I have 360. The 5 is multiplied by the n, so the way that I get rid of it is I divide. And I'm going to get n is equal to 72. That's right, it goes in there. Yep. All right, so what that says is 2.5 inches on the map is the same as 72 inches in actuality, okay, in actual distance. All right, so your homework on this is page 158 through 159, 12 through 16 even, and then 20 through 34 even.